All right, here we are in Excel ready to do a one-way ANOVA. And we have our data here. We have treatment 1, treatment 2, 3, and 4, and all of our measurements for each treatment in separate columns, right? And so this is the exact data that was used in the previous PowerPoint, except instead of group 1, 2, 3, and 4, we just called it treatment 1, 2, 3, and 4 here. Okay, so we got kind of a lot to do here. We're going to start with our degrees of freedom first, just like we did in our PowerPoint. But the first thing I'm going to do is get our grand mean. And our grand mean equals average, and then it's all of our measurements. Enter. There's our grand mean. Okay, awesome. We are ready to go. Now, degrees of freedom between, it's the number of groups minus 1. Now, we could just say 4 minus 1, but just to show you how you might set up something in Excel, I'm going to do count, and count only works. You know what? I will. I'm going to use count A, and what count A does is it counts all filled cells, not just number cells. So then count all of our treatment names minus 1, and there we have a degrees of freedom of 3. Awesome. Our error is our total count. So this one we're just going to do count. And we select all of our measurements minus count A of our treatment group names. Enter. 16, looking great. Now our degrees of freedom total is count. Again, we're going to do our total count minus 1. And there we have all of our degrees of freedom. Now sum squares. This is where we're going to have to start using these here. Okay, so what I'm going to do is I'm going to set up this little table here. This is going to be really helpful. So group, I'm going to use the transpose. That way I can send this array here, and then it'll fill in. So we have each of these groups. Okay, count. So now what I'm going to do is I'm going to do kind of some fancy stuff here, and I'm going to say I'm going to do count and then index, okay? So we select all of our data, and then row number. I'm going to use these indices here. So each of these is going to correspond to 1, 2, 3, and 4, and then I'm going to close that. And what index does is it's going to return the entire row associated with each treatment. And let's see, we have an issue here. Let's just see if we're indexing properly. Okay, we are getting, let's try this one. I see. We don't want to take our row. We want to leave our row as 0, and we want to select column 1. There we go. Now we're getting it. Okay, my apologies there. And then we will just count, enter, and there we go, 5. Okay, so now what we're going to want to do is we're going to want to F4 to absolute reference both of those, and then drag it down, and we see they're all 5 as expected. So now we're going to do a similar thing. So I'm just going to copy this, and we're going to paste that, and instead of count, we want to take the average. 6.6. Perfect. There's all of our means. Okay, so now we're going to calculate our sum square between for each of these groups. That way we would then sum these to get our sum between. Okay, so if you remember, our equation for the SS between is the sum of NI times the squared deviation of XI from the grand mean. So equals count NI times, and we're going to say power, our mean, group mean, minus our grand mean, and I'm going to F4 to absolute reference that, and then we square it. Enter. There we go. And then we just double click to drag down, and everything looks good. So now our sum of squares is just going to be the sum of all of those. There we go, 75.75. This is looking awesome. Error. Okay, so in here we have an error matrix. And what I'm going to do here is I'm just going to select all those. That way we have all of that. Okay, so our error matrix, if you remember, what we're doing is we're taking the sum square of the difference of each value here minus its treatment mean. Okay, So here for treatment 1, I'm going to say equals that minus the treatment mean, right? Okay, but I kind of want to automate this. So here's what we're going to do. We're going to say, we'll leave this, and we'll say minus index. I love index. It really helps out when you're doing matrix stuff like this. And for our array, it's actually going to be this mean column. And we want our row number to be the treatment number. So what we're actually going to do here is, let's see if I remember how to do this. Our row number we want to be, let's try this. Let's try number, and we will take replace that, and we will do start at 0, and then length of treatment space. All right, and fill it with nothing. Oop. Let's see what we got here, because we're getting an error. Okay, take this back out, and yes, still getting an error. Let's try this. Yes, still getting an error. Okay, 10, and let's do replace. Our old text is going to be that. Start number 1. My apologies. Yep. Enter. Too few arguments. New text. Enter. There we go. Okay. So if we go back, we say index of this. Row number is going to be that. There we go. So now we want to absolute reference this, and we want to absolute reference that row. And then if we look there, awesome, we are getting all of those. Go this way, still working. Now all we have to do is take that minus that. And there we go. Awesome. So now we have our error matrix. And then all we have to do is equals sum SQ of all of those values, and we get 47.2. Awesome. So now for our total, we're just taking the difference of each of these from the grand mean and then summing squares. So we can actually do sum square, and we can select this whole array minus the grand mean. And that does not look right. Let me check our one way. Oh, that is right. I guess I forgot what the value is. Awesome. Okay, 122.95. There we go. Now, like I said, super duper easy, these mean squares. We really did all the hard stuff. Just equals our sum squares over that degrees of freedom. 25.25, drag it down. There we go. Now our F is just our MS between divided by our MS error. P-value is going to be equals f.dis.rt, and then our F statistic, our numerator degrees of freedom, because between mean squares was on the numerator, then denominator, because our error was on the denominator. And there we go. We have done an ANOVA. And that wasn't too bad, but let's check our results, and let's use QE Suite, ANOVA one way. We select all of our treatments in separate columns with our treatment names on the top, enter, and there we go. We have our ANOVA table right there. Looks great. And then we have our confidence intervals too, along with our treatment means. Well, that's it for an ANOVA one way. Not too bad. Pretty easy and super duper powerful. In later videos, we will actually do some real life examples to show you how to use it and some conclusions that can be drawn. Thank you so much for watching. Have a great day, and please do something awesome.